Welcome to Spring LIB.
Okay, in this problem we have two charges with positive charge Q2 loaded plus or minus A on the x-axis. And then we have another charge, negative Q1, located distance B on the y-axis above the origin. We were asked if Q1 moves at velocity v0 in the positive y direction, so up in this picture, find what would be the minimum velocity to escape these other two charges. So we can do this problem with energy by noting that if energy is conserved, initial energy is equal to final energy. Must be the case that the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy and final potential energy. So our particle, if it initially has kinetic energy of 1/2 mv0 squared, its potential will be negative Q1 V initial, so the electric potential initially, which equals its final kinetic energy, 1/2 mv final squared, minus the same Q1 in the potential. So for the particle escapes, and we're only trying to find the minimum velocity, we can assume that its final velocity is 0. So this is in other words, this is just enough velocity for it to stall far away. If it's able to escape and get infinitely far away, the potential infinitely far away is also 0. So we can assume these are both 0. So really, this is a matter of balancing initial kinetic energy with initial potential energy. So our initial kinetic energy is just simply this term, and our potential energy will be that due to a dipole, due to two positive charges, which will simply be, just drawing this out once more. This is a distance B, that's our distance A. The distance from each of these positive charges to our negative charge is root A squared plus B squared. And note there are two of them, so we have to use superposition to add together the potential field due to each of these. First, it's Q1, negative Q1, multiplied by 1/4 pi epsilon naught, Q2 over the distance from charge 1 to one of the charge 2s. This is the potential due to a point charge. We have to multiply it by 2 to account for both of them on either side. Set this equal to 0 for balance. And now we can solve for V0. So V0 is going to be equal to the square root of 1/m pi epsilon naught Q1 Q2 over root A squared plus B squared. And that's it. If we add some values for the mass and the charges and the distances, we could determine this escape velocity for this charge.